Hello? Hello? Hi? Hi guys, can you hear me? Okay. Okay, let's give 2 more minutes and we're gonna start. Okay, I think we can start. So, hi guys. Today I'm gonna talk to you about the Neo4j. It's a graph database. So, the scope of this presentation will be very basic. So, did you heard about graph databases before? Raise your hand. Okay, so did you use graph databases in your projects? Okay. Okay, cool. So I think that most of the people didn't use it, so you are at the great place because you will see few things today. So, few words about me. So I'm a software engineer at Software Mind. We have a place on the field. So if you want to see what's happening there, what kind of job opportunities do we have, I'm inviting you. We have a lot of cool gadgets, so you're welcome to see that. So besides that, I'm a software engineer and I'm interested in blockchain data science. In day-to-day basis, I work as a full stack developer. So if you have something in common with those things which I like, so please contact me. We can share our stuff. So on today's presentation, first of all, I'm gonna introduce you. So what is graphs, how the graph history began, and I'm gonna explain you what are graphs and where we can use them. So after that, I'm gonna tell you about how Neo4j connects with Java. And at the second part of this presentation, I will show you some code snippets and how Neo4j browser client works. And you will see that that is a very advanced framework. It's enterprise friendly, so if you have clients which needs enterprise solutions, so the Neo4j will be solution for you. So for the start, like on every presentation about graphs, the graphs journey began on the Königsberg problem. So the problem looks like this. We need to start and finish on the one place and go for each and every bridge only once. So do you think can we solve that problem? Is it solvable? Raise your right hand if you think it's solvable. Okay, raise your left hand if you think it's not solvable. Okay, so the catch is yes, that there is solution for this bridge, but we need to remove one bridge. So Soviets in 1945 did it, but I didn't think that they have solving this solution in mind when they were solving it. So if you will want to start some more advanced journey with nodes and graph data structures, I can recommend those two books. So the first one is more like practical. We have problems which are solved. We have examples, and the second one is more theoretical. So if you will want to deep dive into nodes, graph data structures, and data science, so I would recommend the second book. And let's talk about use cases. So before social networks, what was connecting people which wanted to play chess and social networks? If they lived in the second far away, that they didn't have opportunity to meet each other, and they couldn't interact with each other. So thanks for social networks and graph data structures, right now we have opportunities to connect those people, and this is a big business value delivered because we don't need to create any products. Sometimes we just need to connect people which have similar interests. So that's why the social networks like Facebook, Google, they growth very drastically because the value of the net grows with each and every node which is added to the net. So that's why when we're gonna hit certain point in those networks grow very rapidly. So if we want to create some node data structure just to analyze our problems, I think that Neo4j is the best solution right now because it's enterprise friendly. We have a lot of enterprise support. You can buy licenses, and if you want to just play with it and do some R&D, you can do it by downloading Docker container and play with it. So I think that Neo4j is NoSQL database. It's ACID. It's hosted in the cloud, so you can play with it. You have a lot of sandboxes with data which you can have out of the box, and you can import the data. But I'm gonna show that on the presentation. So a little bit about technicals. So Neo4j use Cypher query language, and Cypher query language is very similar to the SQL language. For example, here is a very simple query, and we can see that we are searching for conference on which person have a relation of the value presence, and we are returning the conference node. So what are the difference between Cypher and SQL? As you can see on this screen, we have a SQL query which is very ugly. It's very big, and I think that just by looking at it, you see that something is not correct. You can do the same query by 2 lines of Cypher. And the next thing which Cypher is good at is to connect between, I would say, like joins in this SQL query, because to execute this SQL query, we will need like something about a minute, and Cypher query will execute in something about second. So if you have a problem when you will need to join many tables, have many switches between tables, joining them, I think that you can consider Cypher as a tool which will be great for that, not only for the performance issue, but sometimes the SQL just won't gonna give you an answer. If you will have, I think, something more than 7 joins on the table, the SQL it will take a lot of time to generate the answers when Cypher will be a few hundred times faster. But not all is roses. The downside of the Neo4j and the Cypher query language is that you will need something about 3 times more space on your server to host the data, because graph data structures are using other mechanism to store data, and you have to consider this when you're gonna host that, because sometimes the AWS bills can kill you. Okay, so is this? It's not switching. No. Nie zmieniają się slajdy. No. Sorry guys, I think that my slides doesn't change. Okay, but I don't think that showing the screen to the audience will be a good idea too. Okay guys, so maybe let's do it like this. The next slide will be to talk about the utils, because Neo4j is a framework which is very advanced. So we have like an epoch library which consists of 450 or more. I think it will be like 650 procedures, which can, for example, make some data manipulation on strings. It could import data. It could create a tree structure of the data, and it could import a lot of big branches of the data, because we can make a batches of the data of certain stance of certain size, and we can precise if we want to import it parallel or not. And the second most popular library is GDS. It's a more advanced library if we would like to have some data analysis, some data algorithms. It's a very great place. And if you will need to search for those libraries, they are available on Neo4j official site. So I think that Neo4j official site is a very good library for information, because you have a lot of good tutorials there. You have sandboxes with a lot of data which is out of the box. And okay, so if that works, it's not bad. Okay, guys. So the second part of this presentation will be how it's easy to use the Neo4j in your project. So practically all you need is Spring application, which you can get from Spring Starter, and all you will need is this dependencies, which is Neo4j dependency, and you can use a Docker container to download a Docker and to work with it. So you will need to specify the name. You will need to specify those two ports, because the first one is for browser client, which we're gonna use, and the second one is for Bolt driver. So to connect the Spring application, we will need to use this one, and we will need to mount a volume on my local machine, because we will load a data from the CSV file, and the rest of it is setting a user password, user credentials. Yeah. Okay. So this is how Neo4j client looks like. Not exactly that, but this. So we will need to log. Okay, so right now we are logged, but our database is empty, and we can't load our data by using CSV loader for our so right now we're gonna load a CSV file from the person CSV, and we're gonna name it as a row. So we're gonna make an alias, and we're gonna create a person node which will have those fields. To be able to work with those nodes, we will need to have an ID field, but it will be created defaultly, and it will be auto incremented. So just in this moment we imported 100 nodes, so we can look on them. And we can see our actual data structures. The data structure looks like this. We have an ID of the person, the birth year, city, and the name. So this is very simple model, but as we can see, we don't have any relations, and this presentation is about social networks, so we will need to create relations between those people. And we're gonna do it by generating relation knows between persons of the same file which we loaded earlier. So right now our structure looks a little bit different. We have relations. We can see how they are connecting people. We can see that we have some tribes here, and we can move those. It's a very cool feature because the presentation of these nodes is looking good. And if you will want to use the presentation of the nodes, you can use existing libraries to present them on your application, because there's a lot of them. And let's now jump to the code. So first of all, to use in Java, we will need to have the properties which they were described on the import. So we will need to have an ID. If we want to have some new nodes, we need to annotate them by ID annotation and generated value. Defaultly, if we're gonna have a field, the node name will be the same as the node as a field name. But sometimes you will need to map some properties from the. They will have different names between nodes and Java clients. So we can do it like this. It's mapped for the same property, but right now I'm just showing you how we can map them. And to annotate relation between the nodes, we can use the relationship annotation and specify exact edge which we're gonna use. So just by doing that, we are able to create a repository. And the repository is very straightforward, because the only thing which we'll need to know is to extend Neo4j repository. And just by doing that, we have all benefits of the JPA in our project. So we can have, we can create a simple queries just by specifying their name. And we can expose them, let's say, on the controller. So if you didn't know that this is a Neo4j presentation, just besides this annotation, everything would look like a normal Spring application. So now we can test those endpoints, and for example, see if it's working when it's up. So now we can see that we have a response from our endpoint, and this is a simple get which we are making for a person gets endpoint, and we have the name of the Sam. His ID is 42 and the birth year is 1970. So we can use that, but we can also specify what kind of query which we want to send to the Neo4j, and it's very easy just by making annotation query and passing the string of the query. So this query, we will find a friend of the guy which we are searching for. And we can see that Sam has 4 friends here. So this is our example query, in which we will need to make a one join between tables. So in this kind of cases, we will prefer to use Neo4j because friend over friend is easy. You can implement it by a one join statement, but we can see friend over friend, and let's see. Here we are specifying the number of relations between those persons. So let's say we can have two steps, so that will be friend over friend. And we can see that in this case we have only one friend of the friend. I did it purposely to show you guys. I can show you in the Neo4j client. So looking on this, we can see that creating bigger queries, sometimes it will be horrible to write that in Neo4j, in SQL, but in Neo4j we can do it out of the box. And right now I'm gonna show you a few more tricks in Neo4j. For example, if we want to play with queries, the suggested way to import parameters to the query would be like this, not by passing the string exactly to the query, because sometimes we can commit them. So right now we can see that we imported few properties, and for example, let's see if we're gonna have exact response. This is a friend of the friend of the sum. So the Ben was only node which was created, and it looks like this. So I'm gonna show you one more query, because those were simple queries. But if we would like to see what is the shortest path between person John and person Emily, I don't even know how we can write that kind of query in SQL. But using Neo4j, you can. This is an APOC library, an APOC method which you can use. So just by specifying the relations, we didn't specify the number of them, but we need to find the shortest path. So it will show search for all the paths, for all the relations. In this example, it's only a no relation, but it will find each and every relation which is on the graph. And when we're gonna want to tune, we can use some more keywords like explain. The explain keyword will show us how the execution plan of this query looks like. So in this case, we are searching from the persons, we are searching for all the relations, and then we are searching for the quickest path. This is just an execution plan. So if we would like to see how this query performs in execution, we will need to profile it. So this is a profiled query. In this query, we have exact DB hits for our exact data model. So we can see if this query is executing correctly as we suspected, because sometimes we have some circular, I would say, branches on our query, and we don't want that because sometimes it's better to make some while statements before getting some circular, because that will kill the performance of our query. And this is a very popular case which you can get when working with Neo4j. Okay, so anybody, any questions about that? Mhm. Yes, yes, yes. Uh, I can show you. Mhm. Mhm. Any relation, any relation. We created the relations right here by using the CSV file, and creating a relation looks like that. You will need to make a create node, the name of the relations, and you can create any. This is, you can create any relation which you need, and you are specifying the second node on which the relation is. You can specify the direction of those edges, and you can do all of that. Mm-hmm. 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 Yes, you can explicitly tell what kind of relation you need. You can have a property on the relation. So, for example, let's imagine like a map graph. So we will have I don't know, distance property, and based on this distance property, you can specify what is the shortest path, because you can have this you can implement that in the Cypher query, or you can implement a method or procedure, and it will work like GPS. Anyone?